There's two main steps when we have a point and we find the slope. So we're going to plug in this point for x and y and the slope 1 into this form and solve for b. Oh, no. There it is. Instead of y, I'm going to put a 2. Instead of slope, I'm going to put a 1. And instead of x, I'm going to put the x-coordinate -1 and solve for b. I'm putting underscores in these places because that's room for numbers. You need to put numbers there. And that's exactly what we're going to do over here. And if I want to clean that up, y equals x plus 3. Writing another equation of a line. Using point -1, 4, and slope is -1. I'm going to plug in -1 for x, 4 for y, -1 for m. Second step, I need a number here, and I need a number here. It's got to be in the form of slope-intercept form. That's what I'm looking for. So y equals the slope -1 x plus the y-intercept we found to be 3. We can clean it up to be y equals -x plus 3. Write an equation of a line using the point -1, 4, and slope is undefined. Going through this the usual way, we typically set up y equals mx plus b, start plugging in points, but then we realize, wait a second, our slope is supposed to be undefined. That's not a number. So it's almost like I need a new strategy for. We cannot use y equals mx plus b. We have to have a new thing. It's a vertical line. The equation is set up different. It has to be x equals a number, and this specific number was supposed to be the x-coordinate, or I believe yesterday we said x-intercept. If I have the point, I'm going to use the x-coordinate to create this equation. If you're going through the process and you realize you've got an undefined slope, you cannot have y equals mx plus b. You have to have x equals a number. Like Friday, what if we have 2 points? We're going to write an equation of a line using 2 points in our graph. Let's use the points -1, 4 and 1, 2. We have a kind of like a previous thing we've got to do. I already have an x and y up here, but I don't have an m, so I have to find slope. Now that I have slope, I can plug a point in, but I need to pick a point. And now it turns into the previous example. We're going to plug this point in for x and y, plug in the slope, and solve for b. Last step is to write the equation of your line. My slope, -1, y-intercept of 3, and we can clean that up. Let's do these 2 points. -1, 0 and -1, 4. Second y-coordinate minus the first. Second x-coordinate minus the first. We call that undefined. When your slope is undefined, we can't do this route. You have to use your other knowledge, other pieces of knowledge. I know if I have an undefined slope, the equation is no longer y equals. It's got to be x equals a number. And that specific number needs to be the x-coordinates of your points. Notice how both x-coordinates match. That's the equation of this line containing these 2 points. Let's check to see if that's right. So the first step is going to be using slope. And we get -3 over a +3, giving us -1. Once you find that your slope is -1 and y-intercept is -5. Writing the equation, cleaning it up, y equals -x minus 5. Agreed. Note, two lines that never intersect. Something to just help you check. If two lines never intersect, that means they have the same slope. I guess I should complete this sentence. Have the same slopes. Or same slope. Other words, parallel lines. Parallel lines have the same slope. Two lines that meet at a right angle, otherwise known as perpendicular lines. They have opposite reciprocal slopes. The slope of this part of the x is -1. The other part of the x would be perpendicular to it. So to check that slope, if this piece is -1, this piece will have the opposite reciprocal +1. Just a little graphic design about other ways you can check this Friday. Does it make sense? Does it meet her symmetric ideas?